Hi, welcome to this module on architecture and installation, part of Certified Kubernetes Administrator series. In this video, we will cover everything you need to prepare and install a Kubernetes cluster, from setting up the environment and installing core tools to upgrading your cluster seamlessly. This particular domain focuses on foundational layer of Kubernetes, how it's built, installed, and configured. We will explore role-based access control, already covered, preparation and installation, Helm and Kustomize for managing configuration and deployment, and operators which help automate complex application management. In this particular video, we will deep dive into the preparation and installation part, the core of getting Kubernetes up and running. Before you begin installing Kubernetes, preparation is the key. You will need a recent Ubuntu version, ideally with at least 2 GB RAM and 2 CPU cores per node. Make sure your nodes are network connected and can reach each other. Then update your system and install basic dependencies like Vim for editing configuration. Once the operating system is ready, the next step is setting up the container runtime, which is the engine that actually runs the containers in Kubernetes. Kubernetes doesn't run container by itself. It relies on container runtime. Common options include containerd, CRI-O, Docker, Podman. For most production environment, containerd is recommended. You can install it through script that will come in the next slide. Next, install the Kubernetes tools, which are the building blocks of your cluster. First is kubeadm. It is used to install and manage Kubernetes cluster. Then is kubelet, which runs on every node, responsible for managing pods and containers. Then is kubectl, which is your command line interface to interact with the cluster. Together, these tools form the backbone of your Kubernetes management workflow. When you run the kubeadm init, a lot happens under the hood. It goes through multiple phases, such as pre-flight, which is checking if your system meets all the requirements, certificates and kubeconfig, generating certificates and configuration files, control plane setup, which is deploying the API server, controller manager and scheduler, etcd setup, which is initializing the database that stores the cluster state, upload configuration and certificates, which is sharing the configuration for future nodes, and finally add-on installation like code DNS and kubeproxy. Each step is crucial to ensure your control plane is healthy and secure. In Kubernetes, networking is everything. Communication happens at different level. Node networking managed by your physical or virtual infrastructure. External network is handled by Kubernetes services. The pod networking is managed by your chosen network plugin like Calico or Flannel. The container networking is handled internally within each pod. Understanding these layers help you troubleshoot connectivity issues effectively. Now let's get hands-on with the installation script first. The first script is to update your system using sudo apt get update and upgrade. The second is the installation of the containerd. The script is shown on the screen. Then is we disable the swap, which is required for Kubernetes. We have to disable the swap using the command as shown on the screen. Then we install the Kubernetes tools like kubelet, kubeadm and kubectl. Then we initialize our cluster and define the pod network CIDR. In this case, we are using 10.244.0.0/16. Then we set up the kubeconfig. And finally, we install a network add-on, for example, Calico in this case. Now coming towards the live demo, we repeat the same step. The first step is to update and upgrade our operating system. Then we install the dependencies. In the next step, we install the container D. Then we disable the swap. After the installation of the container D, we disable the swap. Then we move towards the tools that are required. We install the Kubernetes tools, which include kubelet, kubeadm, and kubectl. We enable some IP table rules. After that, we initialize our cluster using kubeadm init and defining the port network. After the different phases of initialization, we move forward to the setting up the kubeconfig, which is the command is already displayed once you complete the kubeadm init process. You can also see the join command as well, which can be run on the worker node in order to join the worker node to the cluster. Finally, we install the Calico. Now checking the status of our node. Now, as we can see that our node is ready, and we can also see the pod status. All the control plane pods are also in working status. Now in this example, we install the Kubernetes 1.32 version. Now moving next to keeping Kubernetes up to date is essential for security and stability. We start by updating our repository and check the available version. In this particular example, we will upgrade the version of Kubernetes from 1.32 to 1.33. The script that we will be using is flashed on the screen. Now we will move forward to the live demo. First of all, starting with the defining the version. Then updating and the cube atom. During upgrading the cube atom, now we will give the exact version of the Kubernetes or the cube atom we want to install. Here we are using the version 1.3301. The whole process is a bit of time consuming. We have to remain patient in order to change the Kubernetes or upgrade the Kubernetes version. We also have to see for any errors during the installation. In this case, we are allowing the downgrade because earlier I installed the 1.34, but now I want to install the 1.33. Now planning and applying the upgrade. Now applying the upgrade. The version is 1.33. We are upgrading from 1.32 to 1.33. Now we will drain the control plane and upgrade kubelet and kubectl. The control plane has to be drained before applying the version upgrade. Draining means that you are deleting all the pods that are being scheduled on the control plane. Now, as you see that all the pods that were scheduled on the control plane have been evicted. After draining the control plane, we will upgrade the kubelet and kubectl. By defining the particular version, that is 1.33.01 or 01. After the installation of kubelet and kubectl, we will restart the kubelet services and uncordon the control plane so that the pods are again scheduled on the control plane. And this will be our last step. After uncordoning the control plane, we will see the version of our node, and as you can see, just wait for the API server to be alive again, and then checking the version of our node, and yes, it has been upgraded to 1.33. Now, congratulations, you have successfully learned how to prepare, install and upgrade a Kubernetes cluster from scratch. If you found this useful, don't forget to hit the like button, subscribe and turn on notification. Thanks for watching and good luck with your CKA journey. Thank you.